purpose of today's lesson is to solve a system of linear inequalities. The benefit is that what you previously learned on solving or graphing a single linear inequality, you're going to do the same thing today, except it's going to be two inequalities instead of one, similar to what you did when you graphed a system of equations. So, how are we going to do this? Well, first is the graph of a linear inequality shows the set of all coordinates that represent all solutions of the inequality. So, as you recall, as opposed to an equation where even though the points on the line are an infinite number of points that are a solution, in an inequality, what you're going to have are not only potentially the points on that line, but that depends upon whether there's an equal sign or not underneath, but you're going to do your shading again, like we did before. So, let's go through the steps, and then let's go through some examples. We're going to graph the boundary line. We use a dotted line, greater than or less than, and a solid line if it has the equal sign underneath. Same thing as we had done previously. If the equality is in the form of greater than or greater than and equal to, we're going to shade the region above the boundary line. And if it's in the form of less than or equal to, then we're going to shade the region below the boundary line. Similarly, we're going to choose a coordinate in the shaded region to determine if it's a solution to the inequality. As we previously talked about, you want to choose a coordinate that makes life easy. So if, for example, 0, 0 is in that shaded region, choose 0, 0. You can't get any easier with that than that. If it is in the shading, if that point or coordinate is in the region, then the shading is correct. So when you substitute it in, if it makes it a true statement, it is correct. If it isn't, then your shading is in the wrong way. Now, the only tack on that's new here is if we are doing a system of linear inequalities, the last step that we need to do is to label where the shading overlaps with the big capital letter S to denote the solution set. Okay? And then also, let's remember to label each of our graphs, because we have more than one. All right, so let's first start by graphing a single linear inequality. So, my slope is -1/2. My y-intercept is 4. I graph 4. I'm going to use my slope going up 1 to the left 2. It's a negative slope, or down 1 to the right 2. Since it's just less than, it's a dotted line. As I suggested, go from one end of the coordinate plane to the other. Since it's less than, I'm going to shade this whole region below. And since 0, 0 is in the solution set, I'm going to check my answer by inserting 0, 0. And yes, it's a true inequality, so I shaded the correct way. Okay. Now, we're going to still practice with one singular, sorry about that, linear inequality, because we want to make sure you're comfortable with converting these into y greater than or less than, greater than or equal to, or less than or equal to form. So, I subtracted 4x from both sides. I'm going to divide everything by -2. You should recall that when you divide or multiply by a negative, that reverses your inequality. So I get the inequality y is less than 2x minus 4. Minus 4 is my y-intercept. My slope is 2 over 1. Since it doesn't have the equal to sign, it's a dotted line. Since it's less than, I shade below. And what's a point in the solution set? 1, 2, 3, 4. So let's take the point 1, 2, 3, 4, 5, 5, 0. So if I put 5 in for x and 0 in for y. Is that a true statement? And you'll clearly see that that is true. So now let's get to what we wanted to cover today, which is a system. Now, the first equation is set up for us. So I'm going to graph y is greater than 2x minus 5. There's my y-intercept. Now, the other nice thing about graphing the inequalities is I can get away with graphing 1 or 2 or 3 points because I'm not looking for a point of intersection. I'm looking for an area of intersection. Since it's y is greater than, I'm going to shade above. Now, the second equation, or inequality, I have to convert. So I get 4y is less than negative 3x plus 12. Divide everyone by 4. Y is less than negative 3/4 x plus 3. So I'm going to graph that inequality. Negative 3/4 up 1, 2, 3, 1, 2, 3, 4. 4, 1, 2, 3, 1, 2, 3, 4. Since it's still less than, it's a dotted line. And it's less than, so I'm going to shade below. It's a little bit easier to see with the different colors, but where you see the checkered part, right between these two parts of the line, that is my solution set. So, a point in the solution set is 0, 0. So if I put 0, and always go to the original equation to do this. Is 0 greater than 0 minus 5? Yes. Is 3 times 0 plus 4 times 0 less than 12? Yes. So you've done the correct shading. You should be pretty confident about that. Right? And then the final one, I'm going to true this up. 2y is less than or equal to negative x plus 6. Y is less than or equal to negative x divided by 2 plus 3. So I graph 3, which is my y-intercept. Negative 1/2 is my slope. Up 1 to the right, to the left 2, or down 1 to the right 2. Since it's greater than or equal to, less than or equal to, it's a solid line, and I'm shading below. Then I'm going to take my other equation, which is already set up for me. Negative 4 is my y-intercept. 3 is my slope. So I'm going up 3 to the right 1, down 3 to the left 1. Since it does not have the equal to sign, it's a dotted line. And since it's greater than, I'm shading above. And you'll see my solution set's very similar to the one above. It's between these two parts of the line. Okay, in other words, using a different color, the solution set is between this part and this part right there, and that's where the S would go. Got a lot of colors floating around. 0, 0 is in the solution set. So let's check it. Okay, 0 is definitely less than or equal to 6, and is 0 greater than 3 times 0 minus 4, and you'll see that that works also. So, just quickly recap. A system of linear inequalities. What you would do is graph each inequality separately, do the shading, the boundary lines, just like you've been taught, and then the only addition is that where the two shading parts overlap, that is called your solution set, and you mark that with an S.